Okay, what we're mainly going to be talking about are the rational exponents. So what I put up here, these are our old rules that we've seen. So this is review. All right. And just to kind of remind you of the review, if we had like x squared times x cubed, we get x to the fifth. We're going to add the exponents. If I had x to the fourth cubed, we'd multiply x to the 12th, okay? And I don't have it up here, but we've seen this one too. If I had x to the fifth over x to the eighth, it'd be 1 over x cubed because there's 3 more on the bottom. Those are our basic exponent rules. So what we're going to bring in now are the rational exponents, and then the rational exponents will then combine back into these review type rules. All right, so a rational exponent looks something like this. X to the 2/3. So we're saying fractions. So the first thing that looks bad to us is there's a fraction. The part that looks okay to us is still just an exponent. It's just a 2/3 instead of a 5. Doesn't matter. It's just an exponent. But what it means is this guy right here is the power, and the denominator is the root. So I can rewrite this in 2 ways. I can write this as the cube root of x squared, or I can write it as the cube root of x, all of it squared. They're both correct. Most of the time, I'll usually write it as the first one, so I don't have to put the parentheses in. But they're both the same thing. What we want to realize is whatever number's in this denominator, that's the root. Whatever number's in the numerator, that's the power we're talking about. Right? So we've got that example there, but let's say I make a change and I just go like 1/2. Well, that would be a 1 square root. I really wouldn't need the parentheses then because it's just a power of 1. But our square root, remember, understood 2 in there for a square root. If I saw 3 before. So if I make another change like 3/4, fourth root of the cube, fourth root of the cube. We just need to remember which one's which. Okay? Bottom number is the root, top number is the power. So let's get some other values in here. Let's do something like this. 9 to the 3/2. Okay? So numerical ones we can evaluate. Okay? Now, yes, you do have a calculator. You could go do 9 to the 3/2 power, and it's going to tell you that it's 27. But you've got to know how to operate that and how that actually ends up there. Right? So what I want to remember is 3 is the power, 2 is the root. Square root 9 cubed. And so if I just go through my evaluation, hey, we know the square root of 9. Square root of 9 is 3. 3 cubed is 27. So that's where we're coming up with that 27. Right? Now, typically, I will do the root first when I'm doing this because it gives me smaller numbers. So I could also write it like this. Let's kind of review what I was just talking about with the x. I could write it as the square root of 9 cubed, but guess what we're probably not going to be familiar with? What 9 cubed is. Right? And then that big number, what that square root is, it's not that we can't do it. You're just getting bigger numbers. We usually work better with smaller numbers. So usually I'll say do the root first. I can do that in my head a little bit easier than this. And then I'll take care of the power. Okay, I don't want to say one way's wrong and one way's right, but I think you would agree that working with smaller numbers is usually better than working with larger numbers. Okay? So we can do the smaller ones in our head a little bit quicker. So let's go 27 to the 2/3. So we want to remember the bottom number is the root. So I'm going to rewrite it. Cube root of 27 squared. So I'm going to take care of that cube root first. Then I'll take care of the square again so that I have smaller numbers. Okay, so cube root of 27 is 3 squared. 3 squared is 9. Right? And let's look at one more like this. Let's go 16 to the negative 3/4. Okay, I want to get a negative up here just to kind of remind us. Remember, a negative exponent meant that it was in the wrong place. Okay? So this is what we've seen in the past, something like x to the negative 2. Well, let's move that back to the bottom, 1 over x squared. Okay? Just because we have a negative fraction isn't going to change our rule. We don't care what this number is. If it's negative, it's moving down. So I'm going to first rewrite this as 1 over 16 to the positive 3/4. Get rid of my negative exponent. I'm not necessarily happy that there's a fraction there, but I know how to get rid of the negative. So now I'm going to talk about the fourth root. I see 3/4. So 1 over, we're looking at the fourth root of 16 cubed. Fourth root of 16 is 2. So 1 over 2 cubed is 1/8. Now again, yes, you can use your calculator and put in 27 to the 2/3 power and get 9. Okay? But we have to understand what's really going on, because all of a sudden when we get x's, we can't put an x in the calculator. So I need to understand which one's the power, which one's the root, and what's happening there. Okay? So now let's kind of look at some things based on our old rules. All right? So our old idea was, I say old idea, still the same rules. If the bases were the same, I added exponents. If I had a power to power, I multiply. And I had one up there a minute ago where we looked at where the most was. Okay? Don't let the fractions get to you. Simplify. Let's go x to the 1/4 times x to the 3/4. I am still looking at the same base. They're both x's. If I have the same base, I'm going to add exponents. X to the 4/4, or just x. 1/4 plus 3/4 is 4/4. Now the worst part of this is you actually haven't added fractions versus integers. And that's the bad part. Right? Let's look at one, like I had a few minutes ago with the division. Let's go y to the 1/8 over y to the 5/8. Like when we saw division, we were deciding, all right, where's the most? Where are the most y's in this case? Well, there's more on the bottom. Right? 5's bigger than 1. Right? So I got more on the bottom. Well, how many more on the bottom are there? 4 of them. 1 over y to the 4/8, which with fractions, we know this. If we can reduce, we do. So I can go 1 over y to the 1/2. We reduce if we can. Sometimes we can, sometimes we can't. Now let's move a fraction to the outside. Let's go x cubed raised to the 3/2. So that's going to be this old rule right here we're looking at. If I have a power to power, I multiply. I know there's a fraction there, but it doesn't matter. Okay? 3 is really 3 over 1. So I've got 3 times 3/2 would be 9/2. X to the 9/2. Look okay? All right. Now, usually with fractions, where we run into a problem is when we're having to deal with something that doesn't have the same denominator. Okay, so let's kind of look at a few that don't have the same denominator. Let's look at this. Let's go x to the 2/3 times x to the 3/5. So now, in my mind, when I look at that, I'm seeing like bases, x and x. That means I'm going to add exponents, just like I did here. The downfall is I don't have a common denominator. So in other words, to add or subtract fractions, I got to have a common denominator. So we're going to end up with an extra step here. I need to actually get a common denominator, which in this case would be 15 for both. 3 and 5 both go into 15. So 3 times 5 is 15. 2 times 5 is 10. 5 times 3 is 15. 3 times 3 is 9. Now I have my common denominator. The idea of what we're working with today, the rational exponents, not too bad. The exponent rules follow the same rules, not too bad. The downfall is sometimes we're going to have to do some intermediate work like this where we got to get a common denominator to see what's going on. Okay? So now I've got x to the 19/15. I need that common denominator. If I go to a division one, let's go with y to the 5/6 over y to the 7/8. And on the division one, it's one of those things where am I going to have them left over? Well, it depends on which one's bigger. Okay. And even if I knew right away which one was bigger, 5/6 or 7/8, I still don't know right away how much bigger. Okay. Because they're not the same denominator. So I'm still running in the same situation here. I want the same denominator. So before I do anything, I'm going to get the same denominator, and a common denominator between 6 and 8 is 24. That's my common denominator. So now I'm going to build my numerators. Let's see, 6 times 4 is 24, so 5 times 4 is 20. 8 times 3 is 24, 3 times 7 is 21. And now I think it's pretty simple to see which one not only is bigger, but how much bigger. Right? They're both in 24s. We know 21 is bigger than 20. We know it's exactly 1 bigger. So I'm going to have 1 over y to the 1/24 down there. So I think really the worst part when it comes to the fractions is if we've got to get a common denominator, we got to go get that first and then can take a look at what we're doing. All right, let's mix some different pieces in here. Working with our old exponent rules. We're just going to have some fractions in here. Let's go with something like this. Let's go, let's see, 6. Let's go a to the -2/3 times a to the 1/4 all raised to the -4/3. I'm just trying to give you some different looks here, and so you apply your own rules. This looks like a mess. Yeah, we got a's. That makes it nice. We got fractions all over the place. Remember, if you have a power raised to a power, multiply. So I'm going to do that and get rid of the parentheses here. So I'd have a. All right, -2/3 times -4/3 would be +8/9. -2 times -4, 3 times 3. A. 1/4 times -4/3 would be -1/3 because the 4s would cancel. These would be -1/3. Now I'm not finished with this because I have like bases, but at least I got rid of the parentheses. I did something. Okay to that point? Okay. All right. Now, in order for us to combine those, we got to have a common denominator, right? I have like bases. I want to add them, so I need a common denominator. In this case, would be 9ths. So I already have 8/9 on the first one. The other one would be -3/9. Common denominator. Now I can combine them. 8 minus 3, 5/9. Now what we're seeing here is, what you've got to make sure you're realizing, you're hitting apart in these college prep classes, you're getting ready for college math, you get a lot of different forms thrown at you. We need to realize that we're really still doing the same thing. We just got a different look. This is not a very good looking problem. But hey, wait a minute, I know there's fractions. Power to power, I multiply. I'm sticking to my rules, I can multiply those. These are like bases, so I want to put them together. Well, I can't put them together unless I have a common denominator because I got to add these two. Common, put them together. Not a lot new, definitely a new look that doesn't look quite as easy for sure. I mean, let me give you a similar problem. You don't need to write this down, but if I saw this, Man, I would think that's easier. I just would, of those fractions. So, but it's still going to follow the same process. We take that 4 through, and we combine those powers. We just wouldn't have fractions. Okay, so that's the best part. Worst part's fractions here. We're not used to dealing with fractions all the time, and for most of us, we might be pretty good at fractions, but it's usually one of those things in math that's near the top of the list of things we don't like. Okay, all right, so it gives us a different look. All right, let's go y to the negative 1/6 times y to the 2/3 times y to the 1/2. Again, just trying to get a different look here. When I look at that, I'd love to be able to combine those y's because they're all the same base. But the only way I can, because I have to combine the powers, is if they have the same denominator. So I don't care if there's 2 of them or 7 of them. I still need the same denominator to put them to add or subtract them. So even though I've got 3, I'm going to get a common denominator. Let's see, common denominator would be 6. So negative 1/6 would stay on the first one. Second one, 3 times 2 is 6, so 2 times 2 is 4. Third one, 2 times 3 is 6, 1 times 3 is 3. Gets me to that common denominator. So with the fractions, what it's forced me to do is that intermediate step there. Okay. Now I can combine them. 3 and 4 is 7, minus 1 is 6. Y to the 6/6, which is just y, or y to the first, because 6/6 reduces. So again, prior to seeing a rational exponent, we'd have a problem something like this. Again, you don't need to write this down, but that sure looks easier. I can combine a negative 2, 3, and 4. Okay? I'd love to go straight forward with this up here, but I can't until I get the common denominator. That's what's slowing me up a little bit there. Okay? If we throw numbers in, let's go 2x to the 3/2, x to the negative 3 cubed. I've still got that power on the outside. I want to take care of that guy first. Bring that 3 in. I'd have 2 cubed. X, 9/2. 3 times 3 is 9. X, negative 9. I still don't have anything that really looks that great to me, but at least the parentheses are gone. I've got something done. 2 cubes, 8. I can go ahead and make that an 8. Get out of the way. And then I want to combine those x's. The difference is I don't have a common denominator. I got a 2 in one and a 1 in the other. So here comes that intermediate step where I've got to go get a common denominator. And I'd have 9/2 there. And if I want the other in halves, it'd be negative 18/2 in that common denominator. Now I can combine the x's. I've got my 8. 9/2 and negative 18/2 is negative 9/2. 9 minus 18 is negative 9. Look okay there? All right. This final answer would be 8 over x to the 9/2. And what we're remembering on that part is our final answers, our final simplified answers, no negative exponents. Okay, so just move that down. I'm not going to worry about that until I get right here. I mean, on this guy, I had a negative, but when I combined them, it was positive, so I don't need to do any further. All right, combine these two. I've got a negative. Oh, wait, let me move that guy down. Okay, I'm just going through my process. Let's get a fractional power on the outside. Let's do something like this. Let's go 16. Let's make this number 9 here. 16. A to the negative 2, B to the 4/3, all to the negative 1/2. So we got a number, 2 letters, fractions, negatives. We're going to stick to our process. Right? Not going to let all that bother. So I'm going to bring that negative 1/2 in. Right? So back here on number 8, this was 2 cubed because what we want to remember is that was a 1. So 3 times 1 is 3. Okay? Same idea here. That's a 1. So that would be 16 to the negative 1/2. A. Negative 2 times negative 1/2 is 1. Positive 1. Negative times a negative. B. Negative 4/3 times negative 1/2. 4 there twice, that would be negative 2/3. You know, sometimes fractions could be a pain. Look out here. If you went out to the side here, 4/3 times negative 1/2. 2 goes into there, you'd have negative 2/3. Sometimes fractions are easy in our heads. Sometimes we've got to write them out. Right, so let's see what we've learned. We've learned that these two aren't like, so I can't combine them. Okay. We've learned we really don't need the 1 there. It's not going to change anything. We've also learned we don't need negative exponents. Okay, so that means the A is going to stay up top. The 16 is going to the bottom to the 1/2 power. And the B is going to the denominator with the 1/2 or the 2/3 power. I can't combine anything with the A's because there's only one A. Can't combine any B's. There's only one B. Okay? But I can deal with this 16. Okay? Numbers. If we can simplify numbers, we need to. So 16 to the 1/2, how we saw in the beginning of the lesson, is really the square root of 16. Bottom number is the root. Top number is the power. So this is really square root 16 to the first. Well, the square root of 16 is 4. 4 to the first is still 4. So we're looking at A over 4B to the 2/3. And that's as far as I can go. So if we have a number, simplify it. If we have a number raised to a fraction, think about back to how we started the lesson. Look at those numbers to start with. That bottom number is going to be that root. Okay? I don't have anything left to combine. That's as far as I can go. Sometimes I do have things left I can combine. And some of those. Does that look okay there? All right. Let's get